Good day and welcome back to Everything Mathematics. And today we continue our series on coordinate geometry. And today specifically we're going to be looking at functions, domains, and range. Yesterday we established the whole idea of a linear equation, and the day before that we started looking at the whole concept of Cartesian planes, plotting points, x and y values. So what are we going to do today? Today, we are going to, one, understand what is a function and differentiate with a relation. So after today, we should have hopefully a clear distinction between what is a function and what is a relation. Secondly, we're going to understand the concept of domain and range. And last but not least, we're going to calculate the range of a given function. So let's get going. What is a function really? Okay, a function is basically a relation in which each input has one and only one output. For higher learners, you will know this as injective. So it's basically it is injective or it is one-to-one. So for every x, there is a y and there is only one y for that x. No two values can go for the same what? Point, coordinate, x representation, whatever the case might be. Good. A perfect example is this circle diagram here. So if we have x's and we have y, 1 is mapped onto D, 2 is mapped onto B, 3 is mapped onto C. Oh, and map is the term we use when we're looking at what is relating to what in this, what should I call this, in this arena, in this area. So 1 to D, 2 to B, 3 map to C, and 4 map to A. And this is what a function is. So long as there is a one input to one output, it's a function. And the other thing that usually confuses us, I don't know if it's the best way to put it this way or to say it, but I'll say it anyway. We often say that a function is a relation, but a relation is not a function. And that is something that we need to understand clearly. A function is a special type of relation. Good. So a function is a special type of relation in which one element in a domain, I'm sorry I'm using the words already, is mapped onto only one and one element in the codomain. And I know I'm not looking at codomain today, but you'll understand what I mean later down the line. Good. Let's look at a function versus a relation. So you might be asking yourself, okay, if it's one-to-one, or if everybody in X map onto only one to Y, then that's our function. Okay, fine. So what is really a relation? Well, the best way to define a relation is by differentiating with a function. Well, at least for now. So let's look at it this way. We know this is a function. We just look at it. Every element in X is mapped onto one and only one onto Y. So yes, this is a function. Or we could say this is a one-to-one function, or it's an injective function. In the future, we'll learn things like surjective, bijective, and well, injective. And then we have this here. This is not a function. Why? Simple. Because there is one element in A. Notice, look at that tree there. That tree is mapped onto 4 and 5. So that tree there is not that, because of that tree, we are not having a function on this side. But it is a relation. Why is it a relation? Because it does tell the relationship between A and B. It is telling you. And the relationship that it's telling you is telling you that it's not a function. So if we go to plot this by some miraculous way, we would see that 3 will have 4 and 5 at the same point. And that is not hard to believe. It just comes down to understanding functions. For example, and well, I'll jump in a big gun here, but I'll jump in straight to quadratics. In a quadratic equation, you would realize, for example, if we have this curve, and imagine this is our x and this is our y coordinate. Let me draw that properly again. This function here actually represents x squared. And when we draw this function, you would see for any one value of y, and you could see this, right? Without drawing the function, I won't even draw the function, I'll just relate it. This is x over here, and this is y here. And this is the function x squared. And we could see that for every value of y here, guess what? They are 2 x's. So this clearly tells us, okay, this is not a function. This is a relation, because we will have 2 values of x being mapped onto one value of y. Good. So that could, well, no, let me not put it like that now, because that is the reverse. It's actually y gone on to x. Well, again, we could check it out. Moving on. So then let's talk about the domain and the range. I'm not going to address the codomain today, but we're going to look at it this way. So what is the domain? The domain in any given function are any possible values for the x. So the domain is in any given function are pretty much the possible values of x. And notice I'm using the word possible because x could actually be anything. I don't want you to think that x is a set of values, if that makes any sense. Yes, x could be anything. So you have to bear that in mind. And then we have the range. And the range are the possible values of y in respect to x, often given as an inequality, right? And another thing we have to notice here is that the range is basically all the values of y combined as to how low and how high it could reach. And it's not necessarily a specific value. The specific value of y that we find for x it will actually be called the domain. So for example, let me just draw a quick generic value and a quick generic thing. So supposing we have x here and we have y here. Good. And let me say we have 1, 2, 3, and this is mapped to what? Let's come up with some random value here. Let's say 4, 4, 5, 6. Good. Each value here is actually your codomain. That's your each value. But when we talk about the range, we talk about the values from 4 all the way to 6. Those are the range. And those are the values that are normally, generally represented in an inequality. And we're going to see that by the next slide. Good? So that's basically what you need to know. And another thing you need to know, and this is just a notation, you need to understand that y is actually the same as f of x, which is simply saying y is a function of x. So when we're finding the values of y, all we need to know is what is the x value and we put it in the function, and that will give us the value or the what of y if we might want to look at it like that. There is another notation I honestly cannot remember, but I think it's something like x, you have a colon, and I think you have an arrow, something like that. Yes, this is another way to say y or f of x. I will look into it. I could always put it in the comment section after. But yes, that's another way in which you could represent our y on our function. So let's look at this, for example, calculating range. To calculate our range, of course, we must be given a function naturally, and we also have to be given an inequality, as I said. Sometimes they give us as an inequality, or sometimes they tell us plain out, the codomain is 1, 2, 3, 4, 5. They tell us, sometimes they tell us. And sometimes, I've seen in questions, I've seen for CXC sometimes, they start it for you, but then you have to finish it. And how do we find a range? Well, there are many ways to find it. Generally, we use a table, or the table is the generally acceptable, well, I wouldn't say acceptable, the generally renowned one. And we have basically two columns. And we put our values of x and we find the values of y. So we find out what are our x values, which we're going to get from here. And with that, we could find our y values. Remember, f of x is the same as y. So our y value will actually be 2x plus 1. And again, we will know what is our x values with this inequality. Let's read this inequality here. This inequality here is telling us that x is greater than or equal to negative 1. So we know that the first value of x is negative 1 because this inequality says so. It is greater than or equal. So because it is equal, then it could be negative 1. And then it also tells us that it is less than or equal to 2. So we know that 2 is the last value. And x will be the range of values between here. So that means x would be negative 1, 0, 1, and 2. It could be 2 because according to this inequality here, it is less than or equal to 2. And that's basically our values of x. And if we could find our values of x, we can easily find our y values. And how do we go about doing that? We just plot x into each function to find what is y. So in other words, if I want to know what is y when x is equal to -1, I just have to put -1 instead of x. So we go something like this. So in other words, this is another way in which we represent it, f of -1, meaning that wherever you see x, you put -1. And that will be 2, sorry, I put a bracket there too early. 2 multiplied by -1 plus 1. That will give me 2 minus -1, that's -2 plus 1. And here we just have a simple arithmetic. -2 plus 1 is actually -1. So here, when x is -1, guess what? Y is also -1, according to the inequality and the question. And that's how we basically find the values of y, and we could do that for the rest. So now we want to find f of 0, or in other words, we want to find y when x is equal to 0. So that is 2 into 0 plus 1. 2 multiplied by 0 is 0, and that leaves 0 plus 1, so that is 1. So when x is 0, y is 1. Then let's go. Let's find x, f of what? F of 1, positive 1. And you have to be very careful. A lot of students believe f of -1 and f of positive 1 is the same. But no, you have to be careful, because look at what's going on here. 2 multiplied by 1 plus 1. This is actually the same as 2 plus 1. And this is actually 3. So f of 1 is 3. I forgot to change to blue. So f of 1 is actually 3 and not -1. So you see, if you make a mistake and put -1 there, you will get the wrong value. So you have to be very careful. And last but not least, what is y when x is equal to 2? So we say f of 2 is equal to 2 multiplied by 2 plus 1. And if we solve that, we get in 4 plus 1, and that's actually equal to 5. So when x is equal to 2, y is actually equal to 5. And that is how we calculate our range. In the next video, tomorrow, God's willing, I'm going to look at this same function and this same range, and we're going to draw the equation of this line. And as you can tell, this is a linear equation. Well, I hope you could have told, because we have it in the general form. You see this here? This is the same as y is equal to mx plus c. So this function is telling us that the function will cross the y-axis when y is equal to 1, and this function also tells us that this has a gradient or a slope of 2. And that's all we need to know for now. Next week we're going to work out gradient, so don't worry, I don't want to talk too much about it. But yes, this function, I'll use it tomorrow again, and we're going to see how the line of this function look, and we're going to do another one. So yes, this will bring us to the end of today's video. So again, as always, like, share, subscribe if you haven't yet, comment if anything is not clear, and turn on notifications if you want to stay tuned with the next one tomorrow, God's willing, where we look at plotting linear equations. Until then, you take care, have a blessed day.